Okay, so again, welcome to the third Productboard Frontend Meetup. This time we are hosting it online. I was really looking forward to meeting every one of you in person, but maybe next time. For today, I prepared talk Every Millisecond Matters, where I am going to dig into loading timeline. So let's start. But first, let me introduce myself. I'm software engineer at Productboard. I joined Productboard almost 2 years ago and work on various topics touching our front end. You can find me on internet, mostly by my nickname, Huvik. Before joining Productboard, I was working in Vercel as Next.js core developer, where I developed famous API routes. Before Vercel, I was battling databases in Prisma, where I developed first version of data manipulation editor that was predecessor of Prisma admin. In my free time, I enjoy music, bouldering, and spending time with my family as dad. So what we are going to talk about today. First, I'm going to talk about what business problem we face and what setup we had. Then I will go through our first MVP solution, and I'm going to wrap everything with we solved our problems using Cloudflare Workers. So let's start with the business problem we faced. Like always, there is problem with performance and how to improve it. We had same problem in Productboard, so we created battle plan. It should affect all of our customers, and every engineering team should focus on different topic affecting loading performance. Now I will talk about our setup we had. This is going to be a really simplified version. So when user requested our web application, his request was resolved by one specific subdomain. This subdomain acts as unique identifier for user workspace then this request hit our Ruby monolith. This monolith was located in the USA. Afterwards, we got index.html template from Redis. This index.html template was built in our front-end pipeline and then saved in the Redis. Afterwards, we got index template, and we injected some user globals inside of this template. Send it back to the user, and afterwards, user browser started sending API requests to Ruby monolith. Now you can see request waterfall for this scenario. So what we can improve here? There is first request that affects time to first byte. Then we have API request for data. We could improve it by lazy loading some parts of the data. Last but not least, there is JavaScript. We could improve it by reducing bundle size and splitting it to more bundles to increase times execution of JavaScript. So each team selected one of these problems, and our team chose time to first byte. So on this graph, you can see breakdown of the time to first byte of incoming requests. X-axis shows the number of the incoming request, and Y shows time distribution. A lot of requests are saturated around 500 milliseconds and between 1 and 1.5 seconds. As you can see, there is a few really slow requests. This is because users are distributed globally, but our backend lives just in one location in the USA. So when we need to tackle bigger technical initiative in Productboard, we have this process called RFC. It covers most of the problematic parts of this initiative and how we are solving them. And I didn't pick the best name for this RFC because it didn't describe what was actually happening. Server-side rendering is this fancy solution where in React, you render your application on server and then send the back HTML to the users. But our setup was just server-side rendered index.html. That brings us to the first MVP solution. How it should look like. It's easy, right? Just deploy one static file to the CDN and magic happens. So let's implement it. First, we need to create S3 bucket with Terraform configuration. Then we need to deploy a static HTML index to the AWS S3, create yet another Terraform configuration for CloudFront, and another for origins, and list goes on. And finally, we got our setup working, and we were amazed by initial performance. It was great, but it should work, right? But it didn't work. Because, like I said before, we had this cool injection in the backend, and we need to change how it works. So we were building this HTML template in front-end pipeline. Then there was these placeholders where we are going to inject the data, and this index was saved to the Redis. Afterwards, Ruby on Rails monolith got this template from Redis and injected it with user globals configuration. This index HTML was then sent to the user. This implementation was tightly coupled with the backend, and we didn't want to have it like that anymore. We had to refactor a lot of code around this and create new API endpoint that is going to provide us with the user globals. We had to load these globals from the API endpoint before the application ran. Now let's talk about security. Our app is well secured, and one of the safety measures is content security policies. We need to re-implement our backend implementation to the front end, to the static HTML. So we moved our content security policies rules to the front end and use a plugin from Slack that automatically injects policies into HTML template. Speaking of this plugin, we have one PR open for almost 1 year. Yeah, open source is hard when there is no people for that. Great addition of this Webpack plugin was that inline code had nonsense hashes automatically generated by its content, so it was great. And we had to change headers to meta tags. But some meta tags, some headers are not supported by meta tags, so we had to keep some of the headers still. So now let's talk about caching problems. This setup had caching problems, which was one of these downsides. In classic SPA setup, you hit CDN that gets indexed from the S3 or another storage. Then you get a cache hit because this cached, and it's returned to the user, and there is cache hit. But what about nested routes, right? So basically, you check the storage in the nested route, but the index is not there. Because we are deploying just one index, and you can have multiple routes, and you need to create multiple indexes for that, and this doesn't scale. So it's fall back to the error page, and that error page redirects back to the index HTML and send it back to the user, but this is a cache miss. And it increased time to first byte around 300 to 400 milliseconds, wasn't great for us, and we wasn't happy with that. Plus, we have a custom revision system that can point to any revision history. This system supports branch revisions that take last commit in the branch, then commit hashes, so that can point to any commit in history. And you can do this with simple CDN, so we need something better. Plus, we wanted to roll out this feature to keep everything one-to-one with the API, so we can switch between solutions if something goes south. So what now? We need some hybrid solution that support runtime plus caching. There's multiple solutions on the market. So we have AWS with CloudFront and Lambda on the edge, Fastly with Compute on edge, and Cloudflare with Cloudflare Workers. After comparing all these options, we choose Cloudflare Workers. You may ask why we choosing Cloudflare Workers. It's a serverless platform running on V8 isolates. These isolates shares process overhead. So multiple workers can run with one overhead instead of each one of having its own overhead. It can run JavaScript and languages compiled to WebAssembly. There is no cold start because it's handled during TLS handshake. And we wanted to buy more into the Cloudflare ecosystem because we were already using some features from them. But what does it mean to enable Cloudflare Workers? We are using wildcard DNS for subdomains, and if you want to use workers on this wildcard, you need to enable Cloudflare proxy for this wildcard DNS record. But what it actually means, we had a lot of traffic going through from users to directly to the Ruby on Rails monolith. We needed to place Cloudflare proxy in the middle of this traffic. But what happens with the traffic in Cloudflare? Traffic flows through following sequences of the Cloudflare edge. There's DNS protection, URL rewrites, page rules, firewall rules, rate limiting. Then there are workers and load balancing. There's a lot of things that can modify traffic, plus traffic goes through the proxy instead of directly from the end users. Yeah, as expected, we never touched this networking part of our application. It was here from the beginning of Productboard, and that is already a few years. Now we need to place something in the middle that never existed there. So we have a problem. We did a research how this could affect our services, improved monitoring, and change some parts like IP whitelisting. It took some time, but we were confident enough that everything works as expected. So, which requests are intercepted by Cloudflare Workers, you may ask? Cloudflare Workers allows only using wildcard matching, nothing else, which is kind of sad. If you have multiple routes, it matches always the most exact match. Our matching setup was following. We had wildcard for subdomain, because we divide spaces by subdomains, and then we had wildcard for all nested paths, because we are using routing inside of the React application. But what about API routes? We create one whitelisting rule for API routes that bypass Cloudflare Workers and goes directly to the Ruby on Rails monolith. We had to create another rule for the gateway that handled traffic to our microservices. We had to create another for integration, and we had to create 23 custom rules for nested routes to whitelist backend routes, so the requests don't end up in the worker. After all of this, we had everything prepared to run it on production. So we enabled proxy just for one subdomain and set up matching routes so we can catch all requests. Let me stop here for briefly a moment. Maybe some of you already see what could be a problem here. Yes, it's one of these fuck-up moments everybody talks about. This was one of mine. So when I enabled Cloudflare proxy, just for one subdomain, somehow we overlook in our review process that there was misconfiguration. And workers started showing too many requests. We didn't expect that. So we had to turn it off and went back to our DNS configuration to check it out. There was enabled proxy for our www subdomain, and we were showing clothing spinner instead of our marketing page for all our customers. So the fix was on the way with proper routes whitelisting to bypass workers for this subdomain, and we were fine. So after we enabled proxy for all of our customers, we could see a big increase in traffic in Cloudflare. We increased the number of API requests by 4,700%, which was a big number. The same goes for our other metrics like total number of requests, data transfer, and so on. Here you can see a few first hours how our worker handled the traffic. So for a revision system, we were using Redis. but we want to bring it more closer to our customers. So we choose key value store from Cloudflare to store our HTML templates. As always, we were using Terraform for our infrastructure. It's really nice to have because you have your infrastructure in code instead of going through the UI and configuring everything. So Terraform is great. Plus, we have some cool custom keys. First one is current with comma, because you can have comma for the branch name, so this was safe. This shows most recent revision template. Then we have revision that holds current revision hash. And then we had version, what was deployed worker version, because we are deploying workers only when the code changed, thanks to the NX and affected. Here you can see a very simplified version of our worker. So we have this event listener for incoming events from Cloudflare. Then we were parsing the incoming requests to get the revision. After that, we were checking if the request is already in cache. It matches by paths and by headers. And if we don't have a response, we were checking the template key value store if we have a revision. And if we didn't have revision, we fall back to the current key. Afterwards, we created response with this static template and save it back to the user, save to the cache, and return to the user. But we want to have better caching because, like I said before, the caching wasn't great with the previous setup, so we want to have it better. So we want to cache all requests to one response. We want to skip cache for revision, so basically all of the new code is always up to date. We wanted to use web standards like e-tags, and there should be always hot cache from the users. So let's talk about caching all requests. So we have a custom cache key, so we don't match by routes, but by our custom key. We didn't want to deploy worker with every new version of the template. So basically, we had to store the current hash of the template somewhere. So we were thinking, oh, we can use the key value store, but if you read something from key value store, it adds 100 to 200 milliseconds, what is not ideal. So we used secret store inside of Cloudflare and changed the hash in every deploy step. So what about skipping the cache for revision? So if we have a revision, we are not getting requests from the cache, and if we have revision, we are not saving it to the cache. Using e-tags for smaller responses. So we are getting if non-match headers, and then we are comparing if the current revision with the e-tag, what is the template revision, matches. And if it match, we send 304 not modified without body. So basically, we are saving some bytes in the response, and it's faster. And how to warm cache all over the globe, so user always hit the cache. It's pretty simple. You can just do one request in the deploy step, and the cache is warm for users. So it's great. So here you can see improved timeline. As you can see, we improve time to first byte to around 200 milliseconds. Here you can see comparison of first requests. So on the first picture, there is a previous version, and the second is the current one. We focus on the timeline. You can see we improve the time to first byte by almost 800 milliseconds, what is huge. That means we can start fetching data and JavaScript 800 milliseconds sooner for our customer everywhere around the globe. So it's great. So here you can see new requests distribution that moved to around 100 milliseconds, and we lost all slow requests altogether. Now let's compare the old and the new request distribution. As you can see, it's great improvement compared to old version. We moved our distribution to the left where we want it to be, and now we are serve our app to our customers around the globe sooner than before. So our main learnings during all of this was observability is key. This one of the most important things when you are handling this big initiative, and it affects all customers. Changing whole network infrastructure is not easy, and it takes some time, and you can do it all in one go. It's really hard. And computing on edge is future, because it solves problems closer to the customers, and we have better performance there. So let's summarize all of this. We improved time to first byte by average by 80%. There is new serverless platform in Productboard Cloudflare Workers. We bought more into Cloudflare ecosystem, and we can utilize more Cloudflare features like DDoS protection and firewall, so more security for everyone. And it was great improvement in delivering new features using Cloudflare Workers. And now it's time for question and answers. How long did it take you from the initiative to get it to the production? Oh, it took some time because it was like cross-cutting feature that was touching all parts of our architecture. So to align all of our engineers and everything, it took us, I think, half a year, maybe something more. How much it costs per month? I think we pay like $5 or $10. I'm not sure. It's cheap, really cheap, compared to other solutions. Yes, this topic is kind of advanced for me. Okay, it was for me too in the beginning, but if you take some time and try to dig deeper in some problems, you are always solve them. Okay, thanks for the questions. And now it's time for another speaker.